Hello everyone. What's up? What's up, buddies? Yeah. I heard the news. Everyone are talking about WhatsApp 3.5 billion leak, the biggest leak in the data exposure leak in the history, biggest one. Everyone are talking about, right? But I'm going to show how this happened using lip phone number practical demo, raw, real, unfiltered. So in this video, I'm going to share you the truth behind the leak by rewinding the clock. And also I'll show you how it happened using practical lab and also how to fix it. What Meta did, what Meta didn't do, what as a normal user we have to do, and what as a business users perform for protecting in a large scale. Stay with me till the end of this video so that you're going to see something exciting, interesting, and also, no one is talking about and no one is showing about. Let's begin. Let's rewind the clock. Back in 2017, Dutch security researcher Laurent Clogy warned WhatsApp about a dangerous flaw. He showed that attackers could enumerate phone numbers, meaning they could guess and confirm who is on WhatsApp without any permission. His message was simple: if someone can check unlimited phone numbers, they can build a massive database. This was 8 years ago. Fast forward to last year, the same flaw was flagged again by researchers. The warning was loud, the risk was clear, but nothing changed. And now, November 2025, the prediction became reality. A massive dataset of 3.5 billion WhatsApp phone numbers has been exposed. Not passwords, not charts, just the numbers. But that's enough. Enough for targeted scams. WhatsApp takeover attempts, swim, swap, social engineering, phishing campaigns, business profiling, OSINT driven stalking, politically targeted attacks, automated spam harvesting. And how did attackers do it? Not by hacking WhatsApp, but by abusing the same enumeration flaw Collegy pointed out in 2017. In simple terms, the discovery tool meant for onboarding users became a harvesting tool for attackers. This is not a new zero-day attack. This is an old warning, ignored for 8 years. 8 years. And totally, fully exposed. In the upcoming part of this video, I'm going to show you a real demo using lib phone number, the same kind of logic attackers use to validate phone numbers at scale. No hacking, just enumeration. Stay till the end because you will understand exactly how this flaw allowed billions of numbers to leak and how to protect your own. Hit the like button so this reaches more people who need this awareness. Let's begin. Before running any of these practical demos, the prerequisites is installing Python in your machine. So open official Python website python.org and install the standalone version, whichever OS supports your machine, like whether it is Windows or Mac or Linux or Unix. Once the download finishes, run the installer and take the option called add Python to path. This one step ensures your system can recognize Python from any folder. After successful installation, open CMD.
Welcome to this deep dive lab session. We're going to see something most people never get to see: raw, real time demonstration of how attackers technically performed the WhatsApp 3.5 billion phone number leak, but in a fully ethical, safe, controlled environment. No shortcuts, no magic tricks, just pure enumeration logic, trial and error experiments, and the exact tools used in the real world. I'll walk you through each step through my lab, starting with installing the phone numbers library, then parsing numbers, then checking if they are valid, then pulling metadata like region, carrier, and time zone, and finally performing enumeration. The same step attacker scaled into billions of checks during the WhatsApp leak. Every step you see here, every piece of code, every error, every correction connects directly to how the leak happened. Let's start at the very beginning, the installation. I've typed the code python -m pip install phone numbers. This code is supported by all versions of Python. -m is used to run the script as module, and pip stands for package installer. And this looks simple, almost too simple. But this one command is where everything begins in the attacker's toolkit. Why? Because phone numbers contains the exact intelligence about telecom numbering systems that attackers need. It knows every country code, every number length, every valid pattern, every carrier. The WhatsApp leak didn't require hacking WhatsApp servers. It began right here with the same installation you're watching me perform. Import phone numbers. From phone numbers, import geocoder, carrier, time zone. And here we go. These imports, these tiny, harmless looking lines represents the exact building blocks of enumeration attacks. Phone numbers to format and validate numbers. Geocoder to determine region. Carrier to identify telecom operators. Time zone for geo hints. Attackers use the same tools not because they are illegal but because they're completely open source and extremely powerful when used at scale. When it comes to the code number equal to +91xxxxxx parsed equal to phone numbers dot parse num. Watch this carefully. This is where raw strings become structured data. Parsing transforms +91xxxxx into a rich telecom object. When attackers generated billions of numbers, this is exactly what happened internally. Each number got parsed, analyzed, filtered. My one number demo is a miniature version of the massive validation pipeline that powered the WhatsApp leak. Phone numbers dot is underscore possible underscore number parsed. Phone numbers dot is underscore valid underscore number parsed. These two checks right here are the heart of the enumeration attack. Attackers generated numbers like a machine gun, but they kept only the numbers that passed these checks. If is underscore valid underscore number returned false, deleted. If true, kept. This is the first filtration layer in the WhatsApp leak. My demo shows the exact same logic at a tiny scale. Carrier dot name underscore for underscore number parsed comma en. Geocoder dot description underscore for underscore number parsed comma en. Time zone dot time underscore zones underscore for underscore number parsed. The metadata output we are seeing, the region, the operator name, the time zone. This is not just a fun extra. This is exactly how the leaked dataset became so rich. The attackers didn't get metadata from WhatsApp. They generated it using the same modules you see here. When we see a WhatsApp leak entry saying Vodafone, India, Maharashtra, Asia, or Kolkata, that came from this step. For number in range 9000002 9000000 like assume like after 9 zeros and after 9 around 7 or 6 zeros and then 100 which is a range of 100 phone numbers. So and then the code next line of the code is full equal to plus 91 plus str number. Now we begin the section that mirrors the core of the WhatsApp leak enumeration. One number after another, after another, after another. It looks basic, almost childish, but this is the exact concept attackers scaled to billions. Generate a number, parse it, validate it, filter it, repeat a million times, a billion times. This is how the 3.5B WhatsApp dataset was created, not through hacking, but through automation of the same logic we're watching right now. Before we go deeper into the code, I want everyone to understand why enumeration matters. Enumeration is not hacking, it's not breaking into servers, it's not bypassing encryption. Enumeration is simply generating possibilities and checking which ones are real. If I list 100 possible phone numbers and only 3 pass the validation filter, I now know those 3 numbers are legitimate. The WhatsApp leak worked the same way. not by stealing data, but by confirming which numbers were active. So, uh, when I scroll through the code again, for number in range 9 and then 10 zeros, 9, comma 9, and then 6 zeros, 100. It's like 100 numbers range, Indian phone numbers range. Then, then the next line of the code is full equal to plus 91 plus str num parsed equal to phone numbers dot parse full. This part right here is the raw heart of enumeration. I'm generating numbers one by one, converting them to full phone numbers and parsing them. Attackers use the exact same logic, just with a much larger range. Not 100 values, but millions, sometimes hundreds of millions. This mechanism is identical, only the scale ranges changes. I intentionally ran the code with a mistake. Try parsed equal to phone numbers dot parse full. Python throws indentation error, unexpected indent, and there it is, the first error most new developers see. Attackers see these too. Tools don't magically work the first time. This is why I'm keeping this demo raw. Real labs have real mistakes. Real enumeration code often fails on the first few tries. But the attacker behind the WhatsApp leak, they automated error handling. If one number failed, the script ignored it and continued. That's exactly what a brute force enumeration pipeline does. Now I fix the code. For number in range 9, from in the range of 100 numbers, and then the next step of the code is full equal to plus 91 plus str number, then try parse equal to phone numbers dot parse full if phone numbers dot is underscore possible underscore number parsed print full except pass. This is the code which I fixed. Okay, now the structure is correct. Notice how the try except blocks its clean inside the loop. The accept block is crucial, not for this tiny safe demo, but because attackers used it to silently skip errors. A real enumeration script must never stop. If it crashes at 1 million numbers, the attackers loses momentum. So they use except pass to keep the engine running. So now the script prints four numbers from the range. Suppose if it is for 100, it gives plus 9 1, and then 0 1 2 3 4 5, and then 100. And if it is 5, it gives 5 ranges, or 0 to 5. If it is 100 plus 9 1 x 0 to 100, like that. So here, look at that output: clean, simple, filtered. This is the same format used in the WhatsApp leak. Lists, lists, lists of validated, lists or validated, of validated, active international number, active international numbers. My list here is tiny, safe, educational. The attackers list. What about the attackers list? It grew to billions. Same behavior, but different scale. So when we scroll down and add the code, print carrier dot name underscore for underscore number parsed comma en, print geocoder dot description underscore for underscore number parsed en, print time zone dot time zones time underscore zones underscore for underscore number parsed. Now watch what happens when I extract metadata. The attackers does not get this data from WhatsApp. The attackers get it from lib phone number. The same library I installed. WhatsApp only reveals one thing: whether the number has an account. Lib phone number reveals everything else: region, carrier, time zone, formatting rules, validity. Combine both sources and you get exactly the dataset that circulated online. Imagine this script running with not 100 numbers, not 1000 numbers, but 200 million numbers per country across 200 countries. 200. The scale, that is the scale attackers operated at. The WhatsApp leak wasn't a hack. It was a industrial scale version of this tiny demo. My lab shows you how numbers were generated, how they were parsed, how they were filtered, how metadata was attached, and how attackers identified active WhatsApp accounts. Same method, same logic, same tools, different intentions. Right now, we entered into the most crucial part of this entire lab, the enumeration range. The part that directly connects a simple demo to the real technique used in the 3.5 billion WhatsApp phone number exposure, the biggest exposure in the history. So, here in the next section of the screen, you'll notice that I began writing a loop that starts at one number and ends at another. This is called an enumeration range. For example, in my lab, the demo I'm showing, I used something like number ranges from, like from 0 to 5 number ranges of Indian numbers. Like for number in range 9, and then 9 zeros, 9, and then 6 zeros, or the 8 zeros, and then 5. And then the next step of the code is full equal to plus 91 plus strnum. Okay, here I just used the first 5 4 numbers range. Okay, nothing fancy, nothing complex, just a start value and an end value. But this tiny 2-line loop represents the exact foundation of what attackers scaled into billions of iterations. In my demo, I only used 10 to 20 numbers because this is a safe, ethical demonstration. But the logic is identical to the real attack. Attackers simply replaced my small range with a gigantic one. Instead of 20 numbers, They tested billions. Instead of one country code, they tested hundreds. My small range is a microscope. The real attack was a telescope pointed at the whole world. Now let's walk through what happens inside my loop slowly. Parse equal to phone numbers dot parse full. This line takes the raw string and converts it into structured metadata. Country, length, number pattern, whether it fits the telecom rules. Every attacker script had this exact step, parsing. Why? Because if you don't parse, you can't filter real numbers from fake ones. And that leads to the next stage. Inside the loop, I used if phone numbers dot is underscore valid underscore number parsed print full. This checks this check is the exact same check attackers used. This is what lets them remove all impossible phone numbers and keep only those that matches real world numbering patterns. So when you see my lab output printing, it's like plus 919 and then 9 zeros, a kind of, or 8 zeros kind of a thing, and then 1 possible, and then the next range is 2 possible. So and then the same with other countries also, like apart from the India, I have uh, showed some other countries ranges of phone numbers which I enumerated in this lab. So this is exactly how attackers ended up with clean lists of real, active, reachable mobile numbers. And yes, you also saw me face real errors. Indentation error, try expect alignment issues, yep, not defined, unexpected indent, missing colon, mismatched syntax, and this matters more than you think because attackers also go through the same trial and error. They also struggle. Fix loops, fix syntax, fix bad ranges, fix missing try accepts. My raw errors mirror a real hacker's mindset. Test, fail, fix, run again. Before I reached brute force enumeration, I first showed how we can extract metadata for many numbers. So we did something like time zone dot time underscore zones underscore for underscore numbers parsed. Carriers dot carrier dot name underscore for underscore number parsed comma en. And then we used geocoder dot description underscore for underscore number parsed comma en. So this is not just a feature. This is the exact enrichment that attackers added to the leaked WhatsApp dataset. For example, time zone helps identify waking hours. Carrier helps detect SIM type. Region helps determine country or city. So when you saw me print 10 to 15 numbers and each came with a time zone or operator, just remember in the real WhatsApp leak, an attacker did this for billions. Finally, in my lab, I used enumeration for small Indian ranges. And then I demonstrated how easily we can switch the country code, like +1 for US, +44 for UK, +61 for Australia, +971 for UAE, likewise, etc., etc., etc. This is the exact step where you saw how dangerously easy it is to run the same logic on different countries. This is the part where the WhatsApp leak begins to make sense. Attackers enumerated billions of numbers, validated them using the same library, checked which ones exist, fed them into WhatsApp sync mechanism, collected active accounts. The brute force loop in my lab is the baby version of the industrial scale enumeration used behind the 3.5 billion WhatsApp data exposure. Even though I use tiny ranges, even though my demo is purely educational, the logic everyone saw is 100% identical to what attackers abused. Same library, same validation logic, same parsing, same filtering, same country switching, same brute force mindset. The only difference is scale. My demo 0 to 5 number ranges or 10 to 5 number ranges, it's all safe. No WhatsApp calls, no scrapping. Attackers? What about attackers? They did it for billions of numbers, plus WhatsApp queries, plus automated enrichment, etc. etc. Alright, now that you have seen the enumeration range, the brute force loop, the metadata extraction, and all the tiny errors that shaped the code, it's time to connect everything. In this section, I'm going to map every single step of my lab to the exact attacker's workflow used in the 3.5 billion WhatsApp number exposure. The first thing I did it in my lab was install the phone numbers library. This is the same first step attackers take. Not this exact library always, but the same idea. Get a tool that understands global phone numbering rules. Attackers use tools like leave phone numbers, same as our lab, custom validation scripts, numbering plan datasets, or bulk wipe validators. So, my installation step mirrors the attacker's preparation phase. When I wrote import phone numbers from phone numbers, import time zone carrier geocoder, I was loading the exact components that help analyze numbers globally. This is identical to how attackers initialized their validation engines. They need pattern matching, country rules, length validations, metadata extractions. My important statements equal to the initialization logic of the real data collection scripts. Before I lifted the scale, I did exactly what every attacker does first. I tested a single number, parsed equal to phone numbers dot parse plus 91xxxxx. Attackers do this on day one. Validate the pipelines with one number before touching a loop. If one number works, millions will work too. Then in my lab, I used isValid underscore phone numbers parsed is underscore possible underscore number parsed. This is the most critical link to the WhatsApp leak. Attackers use the same principle. Remove fake numbers, keep only the real ones, build clean lists, minimize wasted APIs, hits. My validation checks were the same cleaning filters that attackers apply to billions of phone numbers. Then I showed metadata extraction. Carrier.name underscore for underscore number. Geocoder dot description for underscore number. Time zone dot time underscore zones underscore for numbers. Exactly how attackers turned raw phone numbers into enriched valuable datasets. For example, carrier, Jio, AT&T, Vodafone, Airtel, region, Delhi, Sydney, Dubai, time zone, GMT plus 5, GMT plus 3. This metadata is what makes leaked datasets easy to sell and easy to target. My lab metadata's output is a micro version of the real enrichment pipeline. Before full brute force, I printed metadata for multiple numbers in a row. This step is exactly the same as what attackers do to confirm that the script works in bulk. We tested output formatting, time zone, head lists, carrier names, region mapping, validation speed. Attacker does the same thing but at large scale. Then came the heart of the lab. For number in range 9 and then 2 9 and then to 0 to 1. It's like 1 to 0 to 5 range of numbers. My loop was tiny. Attackers' loops were gigantic. The code structure is identical: a simple range, a country prefix, number parsing, validation, output. Your interpretation loop is a miniature blueprint of the massive real world enumeration that produced the 3.5 billion WhatsApp leak. Every time my code threw errors, indentation error, try, expect, alignment, syntax mistakes, those moments are not failures, they're exactly what real attackers go through. At the end of the lab, I showed how changing the country code from +91 to +1, +44, +971, +61 takes seconds. This is the most dangerous part, and this is exactly what attackers did. My demonstration of switching country codes is the exact mechanism that created global scale exposure. And finally, the attacker step that I never performed, but that completed the leak. Attackers took validated numbers and fed them into WhatsApp sync feature. WhatsApp responded with profile photo, last seen, name, about, online status, and this data became the leak. My lab stops ethically before this step, but everything you saw in my demonstration is the foundation for that.
Meta did not admit a hack. They said the 3.5 billion numbers were scrapped, not hacked. What Meta claims they did, they blocked the automated scrapping method so that the endpoint used to check number existence has been blocked. They said they added rate limiting so that bots cannot test millions of numbers quickly. Improved abusive detection for suspicious lookups. Warned users to enable secure feature 2FA. Coordinated with security researchers to monitor leak marketplaces. Added more privacy controls like hiding online and last seen. What Meta did not do. So they did not delete the leaked dataset because they can't. They did not notify all 3.5 billion affected users individually. They did not admit responsibility because it was technically scrapping, not a breach. So, so as a normal users, what we need to do? So, as we already know, like phone numbers are already leaked publicly, so we must lock our WhatsApp. So, how to lock the WhatsApp? Like enabling two-step verification, add PIN plus email. So, update your privacy settings. Example: last seen to nobody, online nobody, profile photo, my contacts, groups, status, about, my contacts. Prepare for scams because leaked numbers attract fake job messages, OTP scam attempts, fake bank support, malware links. Do not click unknown links. Protect SIM from hijack. Enable SIM PIN. Call telecom and add account lock for verification password. Stop using your main number everywhere. Your primary number equal to for WhatsApp and banks only. Use a secondary number for shopping apps, social media, online registrations, Telegram groups. Watch for suspicious logins. If you get your number is being registered on another device, reject immediately. So, what business users and organizations must do? Businesses face bigger risks. Employees receiving targeted phishing, social engineering, fake WhatsApp support impersonation, business account takeover, customer fraud. Enable mandatory 2FA for all employees. Every employee using WhatsApp, especially business API, must have two-step verification, device PIN, secure email recovery. Train employees. Short training on WhatsApp phishing, fake job or HR messages, fake CEO or manager impersonation, malicious links, verification before replying. Lock company WhatsApp business accounts. Restrict who can change phone numbers. Restrict API access. Enable audit logs. Keep business number private. Protect customer support numbers. Scammers will impersonate official bank WhatsApp support teams, HR departments. Business should put verified green badge. Announce official numbers on website. Educate customers to avoid fake profiles. Use MDM, mobile device management. For employees, work phones, policy based app control, disable unofficial WhatsApp modes, enforce device encryption. Incident response plan. If an executive's WhatsApp is hijacked, immediately revoke device access, notify employees, notify customers, switch communication channels. Isn't it eye opening? Is it, right? Isn't it versatile? Isn't it unique when compared to other 3.5 billion WhatsApp users' videos? Is the content honest? Yes, right. Is it not real? Unfiltered? Is it is it is it that like I break down the security in every possible simplest step so that everyone can understand, right? So for getting such kind of content from me, hit subscribe button and support my channel Tactiles with Bhargavi. Until we meet with the next video, which is going to be more interesting, versatile, and unique, and also maybe practical lab, or we may not sure like what it is going to be, because we can't uh, predict the future, and it's going to be I mean thrilling, and also I'm going to keep it in a suspense and a surprising manner. Okay, so until we meet you with the next time, with the next video, stay safe, stay secure, and keep your defenses strong. See ya.